Alright class, you're welcome to the part 2 lesson of our question series, alright? 20 question series on Le Chatelier's principle. So now question 12, it says, when a system is at equilibrium, the effect of addition of a catalyst on the equilibrium constant will be to A, remain constant, B, shift to the left, C, shift to the right, D, expand it. Now this question is very tricky. Now, they said addition of catalyst or the equilibrium constant will be to. Now this last sentence, this last word, there will be to. Last sentence will be to. We make you feel as if it's going to have a change. There must be an effect. But remember, I told you that addition of a catalyst does not affect the equilibrium position of what? A chemical or an equilibrium reaction. All right. So catalysts have no effect on the equilibrium constant or equilibrium position. So a catalyst does not affect the equilibrium constant or the equilibrium position of a reaction. So the answer is remain constant, option A. Alright, question 13. Now, N2, so all of them are all gases. So they are all gases. So I just have to quickly indicate. So you see that H is positive. So it means our forward is endo, please don't forget. And our backward is what? Exo. But this question, something is missing. Okay, please, for this question, the question is, when you increase the temperature, alright, what will be the effect of increased temperature? Okay, what will be the effect of increased temperature? So the effect of increased temperature, now remember, it is plus. So the forward is endo and the backward is what? Exo. So the effect of increasing the temperature of this reaction is going to put the equilibrium position to the right, therefore increasing the quantity of what? NO that will be formed. So the answer to this question is option C, increase the yield of NO. Then question 14, we have carbon dioxide reacting with oxygen to give us carbon dioxide. In the reaction above, high pressure will favor the forward reaction because, so when you increase the pressure, right, when you increase the pressure, why will it favor the forward reaction? Because you just told you that high pressure will favor the forward reaction. But now, why is it that high pressure is going to favor the forward reaction? Why is it that high pressure is going to favor the forward reaction? Now remember, in order for increase in pressure to favor a particular side of the reaction, therefore means that what? The volume or the number of moles on that side is lower. So if you look at this now, this is 2, not here is 1, 2 plus 1, 3. So this side we have 3 volume, or we say 3 moles. Then if you look at this guy, you just have 2. So we have 2 moles here, and then, or you say 2 volume. So between 3 and 2, which one is smaller? 2. So I told us, if you check my previous videos, that high pressure favor the part with a lower volume or a lower number of moles, while low pressure, that's decreased pressure, favors the part with a higher volume or with a higher number of moles. So the correct answer to this question will become, so in the reaction above, high pressure will favor the forward reaction because the forward reaction is the part with a lower number of moles or is the part with a lower number of volume. So which option matches what I just said? No, not gas formation. B, the reaction is in a dynamic, no, wrong. C, the reaction is exothermic, wrong. D, the process occurs with a decrease in volume, correct. So the forward reaction, these two they react and it results in a lower volume. So 2 volume here, 3 volume here. So that is the reason why increase in pressure is going to favor what? The forward reaction. Alright class, now let's look at question 15. Question 15, we have this N2O4 gas to give us 2NO gas. Now, in the endothermic reaction above, so they are telling us that this reaction is what? Endothermic. They are telling us that this reaction is endothermic. So in the endothermic reaction above, more product formation will be favored by, now more product formation, how will you favor more of, or how can you increase the yield of the product? That's what it simply means. How can you increase the yield of the product? Now, this guy has 1 mole. Using the pressure, remember, let's use pressure. This guy has 1 mole and this guy has 2 mole. So therefore means if you want to use pressure, to increase the product, we will need to do what? Decrease the pressure, because decreased pressure affects the part with a higher number of moles or a higher volume. All right. So we're going to decrease the pressure. So what will be the answer? Okay. A, decrease in volume. No. A decrease in volume. No. B, a decrease in pressure. That's the correct answer. Decrease the pressure. So we have to decrease the pressure. So that's the correct answer. Option B is the correct answer. So when we increase the pressure, it's going to affect this side. It's going to favor this side, not the product. Right? So question 16. N2, nitrogen gas plus hydrogen gas, so 3 moles of hydrogen to give us 2 moles of ammonia, NH3. So delta H is negative. That is telling us that this forward side, the product side is what? Exo, and this side is what? Endo. Alright? This side is exo, and this side is what? Endo. In the equation above, the yield of ammonia can be decreased by the yield of ammonia can be decreased. So it means that what will not favor the forward direction, meaning that what is going to favor was the backward direction. All right. So we know that this minus is telling us that the ammonia is the side of the ammonia, which is the right hand side, the formation of the ammonia is exothermic. So in order to increase the yield of the ammonia, we have to decrease the pressure, because decreased pressure favors exothermic reaction. But in this case, all right, they are asking us the yield of ammonia can be decreased. So how can we reduce the yield of ammonia? So using temperature, what we'll do is that instead of us to decrease the temperature, which will favor the yield of ammonia, because that side is exothermic, we are going to do what? Increase the temperature. All right, and so we are going to increase the temperature. How do we decrease ammonia? So we look for increased temperature. Is there increased temperature here? Yes. Increased temperature, option D. So that's the correct answer. Option D, increasing the temperature. Now, why is C wrong? Increasing the pressure is because this guy 1 plus 3. Yes, we have 4 moles. All right. Here we have 4 moles, and here we have what? 2 moles. Okay. Now, considering this, increasing pressure. Now, high pressure favors the part with a lower volume. Okay, so increasing pressure is wrong, because increasing pressure will favor this side with a lower volume. The question is asking us to how do we decrease the yield of ammonia. So yield of ammonia can be decreased by, so we are decreasing the yield of ammonia. How do we decrease? So please don't want to pick increasing pressure, because increasing pressure, you are only going to increase the yield of ammonia, not decrease it. All right, now question 17. When at equilibrium, which of the reactions below will shift to the right if the pressure is increased and the temperature is kept constant? So temperature is constant, we are not considering temperature, right? We are only considering pressure. So when at equilibrium, which of the reactions below will shift to the right? So which one of the reaction will shift to the right when we increase our pressure? Which one of the reaction will shift to the right when we increase our pressure? So shifting to the right when we increase pressure. Remember, increased pressure favor the part with what? A lower volume or a lower number of moles. Right? Increased pressure favor the part with a lower volume or a lower number of moles. So here, 2 plus 1, 3. Right? To the right. Remember, we are considering the right hand side. So 2 plus 1, 3. Here is 2. So increased pressure will not favor this. Right? It will have to be decreased pressure. So A is out of it. Then B, 2 moles here, then 2 plus 1, 3. Still not work, because you have 3 moles at the right, 2 moles at the left. So increasing the pressure will not favor the part with a higher number of moles or the part with a higher volume. So the answer is obviously C. Now, why is it C? Because here we have 2 plus 1, 3. So we have 3 volume or 3 mole. Here, and here we have 2 mole, or we say 2 volume. So increased pressure will affect the part, right? It's going to shift the equilibrium position to the right hand side. Why? Because this side is a part with what? A lower volume or a lower number of moles. So that is why C is the answer. Now let's move on to the remaining 3 questions. Here are the final piece of these question series on Le Chatelier's principle. All right. So now question 18, we have P gas plus Q gas to give 3 R solid plus this, and then we have theta H negative. Which of the following will increase the yield of R? So how do we increase the yield of R? Now let's use brain work for this, even without looking at the options. How do we increase the yield of R? We either remove arrow as it is formed, or we add to this side. Then since we are seeing negative, so this direction is what? Exo, and this direction is what? Endo. So that simply means we are going to either remove arrow or add here. Then we are going to decrease temperature. All right, and then we're also going to decrease pressure. Okay, because this side is a part of the higher volume. This side is 1 plus 1 2. This side is 3 plus 1 4. So I'm going to decrease pressure, decrease temperature, or we say we add or remove. So now let's go through the options. So which of the following will increase the heat of A? Using a larger closed vessel. This is totally out of it. B, increasing the temperature. Increasing the temperature is wrong. Increasing the temperature is wrong. When we increase the temperature, this side is favored, so it will not increase the heat of R. Then C, removing some of S. Yes, removing from this side favors this side. Very correct. So C is our correct answer. Then D, I told you guys, catalyst does not affect the equilibrium position of a reaction. So take note, even if they call it positive catalyst or positivity catalyst, it has no effect on the equilibrium position of a reaction. Then we also have this gas. In a reaction, a decrease in pressure will, what will a decrease in pressure do in this reaction? Now, which side has a higher volume? This side, because 1 plus 1 is 2. So here we have 2 volume. Here we only have 1, so 1 volume. So increase in pressure favors the side with a lower volume. This is the side with a lower volume. But the question says decrease pressure. So decrease pressure will favor the part with what? Higher volume. So which is this part? So this part is favored. So it therefore means that the yield of PCl3 is increased. So that becomes our answer. Option C. The yield of PCl3, this is what we have here, all right, is increased. Although it's these two that will be increased, but then one of them is just in the option, so pick it. Then lastly, question 20. Chlorine plus water give us this. Then we have theta H is what? Plus 115 kilojoules per mole. In the above equilibrium reaction, a decrease in temperature will. So what will a decrease in temperature do in this reaction? Now remember, we are having plus, so forward is what? Endo, backward is what? Exo. So when we decrease the temperature, definitely it's going to favor what? The backward reaction, which is the exothermic, because decreased temperature favors exo, increased temperature favors what? Endo. We have A, it will favor the reverse reaction. B, favor the forward reaction is wrong. Decreased temperature cannot favor endothermic reaction, which is the forward. Alright, so the only one that makes a lot of sense is A, which is very correct and accurate. Favors the reverse direction, which is this backward reaction, So this brings us to the end of our question series on the Chatelier's principle. Please do well to like, subscribe, and share this video to your friends. And if you have any question, please do well to drop them in the comment section. And I'll see you in the next video lesson.